Morning students. Today we are going to discuss about the separation techniques. In that, first technique is the flame photometry. In that, in part of that, we are going to discuss the flame photometer. Here, in our first year syllabus, I think we have discussed about the colorimetry and spectrophotometry and some of the some of the instrumental techniques. In our second year, we have different types of separation techniques here. In this technique, we are going to separate we are going to estimate we are going to determine the quantitative estimation of the some of the elements, some of the substance present in our body fluids like serum and different types of fluids here. If you see the flame photometry here, which is also one of the technique here, but the main difference of the colorimetry and flame photometry in the sense, the light source is the main difference here. In our colorimetry, we have a light source and different types of filters and selectors. Then we are going to take the cuvette like this. If you see the flame photometry, we are going to focus the optimizer here. So if you want to estimate the sum of the substance present in our body fluids, you should take the sample in the optimizer here liquid sample here. In that you have to take the sample here. By using this flame, by using this sample here, we are provide the flame here. But here we are provide the fuel and air here. This is the optimizer. This optimizer will provide will give the flame here. The flame intensity is directly proportional to the sample or substance present in the patient sample here. If the substance, that means if the sample is having more number of elements like sodium and potassium, some of the electrolytes, basic about the concentration of the ions, the flame intensity will increase. By using this flame, we can filter the wavelength of the light here. Then we will record the intensity of the color here. This is the main object of the flame photometer. That means the color intensity, the light intensity directly proportional to the concentration of the substance, concentration of the elements present in the patient sample here. We have to take the patient sample in the optimizer here, which gives the flame here. Flame intensity directly proportional to the concentration of the substance present in the patient sample here. By using this technique, we can estimate the sodium and potassium like electrolytes here. Chlorides, different types of electrolytes we can estimate here. Here, main intensity of this technique is we have to estimate the quantitative estimation of the electrolytes like sodium and potassium ions here. Here, these ions are very, very important in our biochemical reactions, metabolic reactions here. So if you want to exist, if you want to be